So hopefully everyone enjoyed the very yellow spread.
Yes.
It was very, right?
It actually said yellow drinks.
I know, assorted yellow drinks. Yeah. Great. We have a little switch up in the schedule to accommodate people coming and going. But yeah, this is machine assembly with MoveIt with Felix.
All right, thank you. I was moved up, like you just heard, and this is a great excuse for me to have quite thin slides at the end of this. This is the sort of talk that comes together at the last minute, so you have to bear with me. So it's going to be split in two, this machine assembly and UX talk. The first bit is about my experience using MoveIt for machine assembly and what my takeaways were from all of that, and then some UX and feedback that I got from users and from groups and friends who've been using MoveIt for a while. And I'm trying to start up with MoveIt, and I'm going to try to transmit their suffering to you because it matters. But just to start, just as a little bit of background, I copied this slide from my professional stuff to say I'm not a computer scientist by heart. I actually came from mechanical engineering. So my robotics career, so to speak, is maybe 4 or 5 years old, and my experience with ROS and MoveIt itself is maybe about 3. So I have a unique sort of view, I feel, in some ways, compared to people who are really in deep computer science. The robotic stuff that I did was mostly competitions and haptic and tactile stuff. And I was also part, like some of the people in the room, of the Amazon Robotics Challenge. Like fewer members of the room. I didn't win it, but we got to the finals. That's good. In the top left, that first robotics competition that I tried, we won by chance. But that was without Ross, and that's ever since I noticed we can't live without it. The suffering was intense. And the bottom is the World Robot Summit Assembly Challenge, which I'm going to talk about now. This World Robot Summit Assembly Challenge is, or has been, in 2018, the pre-competition for the actual event that's going to happen next year. The Japanese government decided to make this World Robot Summit happen roughly at the same time as the Olympics in Japan, so we're going to have like Robot Olympics. You get it. So last year the task was to assemble this drive unit. And when you look at that task, as it actually happens, it's insane. If you look at the details of what has to happen with the robot, you go crazy because there's so many little details that you have to think about and have to parameterize discretely. Look at holding this and then fixing the screws in this pulley, or picking this thing up, this retainer pin, putting it in and then putting more stuff on it. And when you push it into the hole here, you have to keep your finger on the back, otherwise it falls off. So all of this with parallel grippers is not trivial at all. It's going to be a lot of pain to code, even for expert users. And as if that wasn't hard enough, there's actually also a surprise part that you get a day in advance. So you have to keep your system flexible, is the idea. This task I love. It's a great benchmark if you ever consider doing this. All of the parts are online. You can buy them at Misumi. It's all almost off the shelf. I especially love the sprockets here. This really is fun. At the moment, all of these assembly tasks that you see in industry are done pretty much like this. You separate the task, divide and conquer style, into very specific subunits that you can code feasibly as a user, as an expert user, as a robot applicant, or a system integrator. Here in the middle, I'm not sure if you can see it, right, is a jig that's specifically made for the type of parts that they're picking. And as soon as the robot drops the part into the jig, it's really well known. The orientation is precisely known. And then you can basically teach and play back the whole part, or the whole task. And that's how it's done almost everywhere. This is the best we can get at the moment. Nothing else is really feasible at the moment. Everything else is too slow or too complicated to set up. So that's what the competition is about. That's what we're trying to overcome. So the system we built to make this drive unit come together is a 3-robot system together with Osaka Uni and a few other subgroups, the Sansoken, the AIST in Japan, And it's 3 UR robots, 1 custom gripper, 2 general purpose grippers, the robotic grippers, and a set of tools. And this tool arrangement is pretty interesting. I'm going to go into that later. The setup is like this. You get these trays with the parts, and you have to put them together here in the middle, in between the robots. And the end result looks like this. This is already a few minutes in. The robot picked this screw tool. It's going to pick up its little screw. Then this robot is going to put the plate here on the base, and then we're going to screw it in, and it takes forever, and it's really difficult to check if everything worked right. In fact, this is one of the easier tasks to check the success of, because you have the motor in the screw tool telling you if it can spin more. But as soon as you have to do something that is complex, for example, inserting something and then seeing if it's still there, it's a complicated vision problem, and it's not as trivial as all that. So what else do we do in this system? We set up this tool arrangement in a way that we didn't have industrial tool changers. We wanted for the robot to be able to just pick up something like a human would, a screwdriver, and use it like that. And that's part of the big motivation behind why I implemented the subframes that Dave already mentioned earlier. There was other things, other little strategies that we had, like compliance and some joints to allow us to not know exactly where the part is and still succeed in our task, and avoid any jigs, because jigs are not the future. I looked at what the other teams did in that competition just for your general knowledge, because it's interesting stuff, in my opinion. And on the left, you kind of see us and other more academically focused teams doing sort of self-centering and custom gripper operations and strategies. In the top right, this is the third place FA.com, so the FANUC System Integrator Group. And this is a really complex, really rigid setup, and they were the only ones in the whole competition who finished the unit. No one else managed even most of it. But they all did it with complete CNC teaching and playback, so it feels kind of dirty, to me at least. It's too bad. But it shows us that the hardware is there. It's a software problem. It's a planning and how to write it sort of problem. And I also saw that different teams tried different, well, specialization is how I called it, but there's teams who did use jigs or special shovels for this kitting task. Kitting was also part of the competition. So each part had a different shovel. You can do it, but I'm not sure, it doesn't really feel like what I grew up with as a kid. That's not what I expected the robots of the future to look like. Not quite yet, at least. Anyway, what came out of this competition is not only that knowledge, but also all of our example code, because we put that up, like I mentioned in my lightning talk at Roscon. This whole solution as it is online. So I see people taking photos of the site as if you use it. One part of it, by the way, is a generator for this sort of assembly for the MoveIt scene or for URDF, and an example of a multiple robot system, and all of the task instructions. What next is what I asked myself after we finished this. So one of the pain points that we had is that there's no good way to write how the robot should perform the task unless it's all manual. It's a lot of writing, and like I said, part of the motivation behind the subframes was using tools, but another part was another part of the motivation was if you can pick up a part and then tell the robot to do something with the part instead of its own joints, then you're already a lot of the way there. So that's part of the top left video. Another thing that we submitted to ICAR that hopefully gets through is a pose estimation package, which is not released yet, but the basics are there. It's going to come out. One of the difficulties with this problem, with the whole assembly task, is that the tolerances are quite tight, to the order of 1/10 of a millimeter. And if you don't know exactly where your part is placed, and you have to do a spiral search all the time, unless you have a very precise and capable robot, you'll fail quite often and you'll end up in protective stops. It's going to be much less reliable than you need it to be. You need high reliability for anything that you want to use in an application. So another thing that surprised me, by the way, is that camera calibration is also much more difficult. Because I'm not a computer vision person, this surprised me, and not as precise as you would need it for this sort of application. So one of the ways that we propose to deal with it is to, I hope you can see it in the video, just touch the environment as soon as you have a part, and then you know pretty much where it is in your gripper, right? And that's how we localize it in the hand. There's more things, there's more approaches that I don't want to get into in detail. We're looking into using tactile sensors. Hard to do in MoveIt. We use compliant joints, even harder to do in MoveIt. But that's not what this is about. Like I mentioned, one of the big challenges we had in writing the task was that it's hard to check for success with the robot. It's hard to know when a task really succeeded unless it's simple binary checks. And that's why the current state of the art relies on jigs so much, because you can always check, did I get it? Is it there? And if yes, proceed. If you don't have this very binary success metric, if you have to rely on cameras to look at the assembly, for example, and check, is this peg in this bearing? It's going to be difficult to do that in different environments. You have all the lighting problems, all of the difficulties that plague any vision problems come up. And you don't have to do it only for this peg, you have to do it for all of the 30+ parts in this assembly sometimes. So this isn't easy at all. And I've been thinking a lot about how to write this easily and what sort of framework we will need to do it. Some other notes from what from my experience doing this is there was actually no best practice that I found for running multiple robots with MoveIt. There's different ways to do it. For example, defining them all in a single URDF, or putting them all, or defining all of the robots as a set of joints in one move group, or putting them in different move groups. But if you put them in different move groups, then you end up, if you use them at the same time, them not knowing their motion plans, so they might collide. For simplicity, what I did, or what we did, is we did use the multiple move groups and we just didn't do simultaneous motions. But it's not optimal, and there's no one to tell you how to do it, so that was the pity. I think people would like to have that. Another thing that I noticed is the students that we had from Osaka University were struggling to learn all of the many pieces of knowledge that you need to be able to use MoveIt and ROS and everything in the time that they had, which was not a lot at all. So what I ended up doing, what I think is what many others have to do when they've set up an application that is more close to the actual thing they're doing, that is not very generic, is I wrote a custom little wrapper for them. So they can write in smaller units, like pick and place, which I know is integrated in MoveIt, but in our case it was a simpler version that's deterministic, just go down, go up, sort of things. And because we had multiple move groups, I also didn't want them to learn how to deal with that object, etc., so I made a custom MoveIt function. All that to say, there's yet another layer of usability and ease of use that real newcomers expect. That was my impression. That's my seg, by the way, into the UX part of this talk. Like I said, I'm from mechanical engineering, and one of the things that I uniquely remember is if you design something mechanical, if you design something that's safety related, there's different ways of making it safe. The one way, or one of the best way, is to avoid the possibility of accidents. Just for example, if you make this road here, make it larger so people don't fly out of it. Or if the second one is to reduce the impact of your accident, so put up a guardrail around the road. And the third one is, please don't go too fast or you'll die. Just put up the sign. And in our case, the accident, or in software design, the accident would be a user having a problem and not finding out what to do and having a really frustrating experience. It's traumatizing to new users because there's much more lost. And they have much less knowledge and the capability to find their problem sometime, or what their problem is about, than we do. So I think it's important to always keep in mind that when someone uses the software, they're very likely actually to have very little peripheral, or how would I call it, system knowledge about what is going wrong. So the goal should be when we write code, or when I write code, I try to think what can go wrong, what can users do wrong, what sort of error is likely to happen, what sort of message do they need to either be able to Google and then find a good tutorial or a good solution, or what can I do to avoid that in the first place? What is a good default, et cetera, et cetera. So there's a little bit of an analogy with the road design. Try to, if you can at all, if you write code, try to make it in a way, or try to write it in a way that people don't even have to think about what could go wrong. If it just works without any problems, that's the ideal case. That is just perfect. One of the problems, obviously, is we don't really know who to write for sometimes, because there's so many different audiences to MoveIt. This is also part of the panel discussion I saw in the schedule. But we have so many different levels of expertise that the software is catering for. Between people who've never really used a robot, between students and people who just work in a garage or just want to make their 3-axis robot work, up to people who need high-level or high-speed control. And they all have different expectations, or slightly different expectations. So it's really something I think is worth discussing. Now, I said I'd collect user voices, and I just, since I had no time, put them all up on the slide. These are the main comments, the main threads of comments that I saw, or that I received. And it's noticeable, or noteworthy in my opinion, that many of them relate to defaults. Like, why is the planning doing this funky stuff? Everyone who started MoveIt has had that happen. Is there a good way to constrain a robot? Every time you demo this out of the box, someone thinks, what the hell is going on? What do the planner options mean? Sorts of documentation-related comments. What are good defaults? What do they mean? What are the planners at all? Why is my plan failing? Why isn't it doing what I want? After a certain level, obviously, you need to be a little bit of a roboticist and just go through your system and try to figure it out. But I think there's more we can do to help new users find what the problem is. Is there an attached object that's blocking things? Is it the joint limit that's the issue? Is it a collision happening right at the start? Can the error be more verbose? Can it be easier to understand for new users, et cetera, et cetera? That's my takeaway from this list, at least. So, in conclusion, from the first part of the talk, or from my experience from the assembly task and all the implementation from that, I found that setting up complex tasks was much more difficult than I wanted it to be. And I wonder what sort of higher level planning we might have to implement, or we want to implement. Not necessarily MoveIt, but what sort of system will MoveIt connect to? What are the interfaces? Is there a recommended state machine, for example? Is there a way that in the planning scene we could have an assembly being planned or a task being executed, since there is already a concept of a task in the MoveIt task constructor now? What is the target? What's the goal there? What part of it can be in MoveIt? What part of it is actually motion planning? And if not, if it shouldn't be in MoveIt, how can we connect to it? It's something that's been on my mind. It's not really a conclusion, it's actually a new point. I also saw that it's a great tool, and it's pretty close to what I want, but I wonder what layer MoveIt will be working at. It's sort of the same point in a different formulation. And in terms of user experience, I thought, it's getting there, it's good, except for some defaults and some smaller points that I already mentioned. I guess I'm going to go into the question, because now it's 5 minutes off. Thanks.
Do you have any questions?
So So I found your point about defaults actually quite interesting because MoveIt used to have lots of defaults and tried to plod along even if something was not working, not clear, unspecified. And that actually frustrated people to no end, especially new users, because it started doing things which were even weirder than the stuff that you already sort of mentioned. So I'm curious if you have any ideas how we should approach this defaults thing, because ideally, actually, we'd like to fail early, fail hard. At least that's what I like, because then it at least know what is going wrong, or that something is going wrong and it's not doing weird things. So, do you have any ideas, any tips? Because I'm going to make you implement the default, so think hard.
There were two things in my mind. One is fail early, fail hard. That's true, especially for startups, etc. When you do something that's safe, I'm not sure that you need to fail hard and early. I don't know that if someone just wants to have their little robot walk around or touch something, they need to, unless if the movement itself is safe, I am not convinced that we do need to have that same paradigm all the time. We can allow some leeway, I think. Then second, what sort of defaults do you want? It might have to do with the same, it might be related to different audiences and different expectations. Different use cases would require different defaults, I think. And it might be difficult to choose the right one. I'm actually not sure of that. I'm not as knowledgeable about the history of these defaults. And I wonder what could be weirder than a robot spinning through the table. But it's for sure something you need to take a close look at.
That's fine, I'll put you on the spot. I was just wondering if you have any.
I wish I had a better one, for sure.
Yeah.
It's fine, thanks.
So I think we do have so many defaults, making all of them explicit takes a very long road until you get any success at all, right? So I'm not sure we can get rid of the default.
Yeah. There's one of the things that you hear a lot from users of MoveIt is that being able to go through the tutorials and just run things through RViz really leaves this deep impression, wow, this is great. And then, which is all kind of abstracted away from customization. And then, as they then go into MoveIt, we tell them don't use Move Group, don't use RViz, learn the C++ API so that you can use the pieces and use all of their functionality. So maybe it's not so much coming up with specific defaults, but paving the way from, set it and forget it, you don't need to know what's going on, to you want to customize this to your very specific application. I don't know why I jumped in there.
That's true. One thing from a user perspective you have to keep in mind is that more defaults, like you put it, might actually just be the forest of choices that you don't want to have. I would never try to have more than 2 or 3 defaults available because it's confusing. Choice is oftentimes worse. It's one of the plagues of open source software, sadly.
So, documentation and tutorial.
Actually, just starting, go for the MoveIt, but actually I don't think documentation tutorials should be it. I don't think new users should have to read everything to be able to start. A good default is something you don't even notice that it's there and working.
So I have one question regarding the assembly task. One of the issues over there was visual inspection to checking if things are done correctly. Could you share some more thoughts and ideas you have in this space? What alternatives we can have to visual inspection?
Alternatives to visual inspection during the assembly task. Like I said, at the moment, the state of the art that I see is make a jig and check binary. Is the part there? Is everything completely controlled and successful? Usually what I saw people do and what we also did is in a similar way, binary checks were, apart from jigs, is the grasp complete, gripper opening width, force checks, are you going close enough? If you're approaching the object and do you hit it, is something you can check fairly easily, as long as you have the measurements and the force sensor on your robot. In that screw tool down here, I think I mentioned this. If you have a separate actuator that you feel is blocking, or you know your screw is tightened, That's maybe the only or the most common things that I've found. Like I said, it's difficult to use vision for reliability and because it's so hard to set up and these constraints. Yep.
Great. Thanks again.
Thank you.
Next up, we have